All right, let's go over, well, this problem is number 5 on this student's Unit 2 practice test, but it may be a different number because I think I scrambled these questions when you were taking it. But if it's number 5, make sure that it says 5.2-23. We'll go over this problem on this video. Suppose P of C is 0.048 and probability of M and C is 0.044. And the probability that it's M or C is 0.524. We want to find the indicated probability, the probability of M. Now this is very confusing looking with just a probability notation. So what I'm going to do is I'm going to draw a Venn diagram, okay? So take a look. This is my, I'm going to go ahead and write over here. See if I can make this a little bit bigger. I can't really make this bigger, but let me go ahead and draw what's going on so far, okay? So the probability of C and M. So we have C and M going on, and I'm going to go ahead and draw one bubble and call this C, and I'll call this one M, okay? Let me zoom in a little bit so that you can see better. All right, but do you understand why they overlap? They overlap because of this part right here. The probability of P and M and C, the probability of M and C is 0.044. So approximately 4.4% is in this area where they overlap. So both in C and M. So we put that number in there. This is probability of M and C. And what they also said is, now I'm going to go ahead and use a different color here, okay? The first part, they did say that the probability of C, the chance of being in C, and what they mean by the C is this whole yellow thing. Okay, the whole yellow thing is equal to 0.048. Okay, so you need to understand that 0.048 is this shape plus this number, right? This overlapping area. So in order for me to find out how much is in this blue shaded shape, or the area or elements that are in C but not in M, what I'm going to do is I'm going to subtract, okay? So how much is in this blue area? We're going to have to do 0.048 minus 0.044. If you subtract them, you will get 0.004. So this much is in C only. That much is in C only. Now, what else do we know? They also said that the probability of M or C, that means all of these bubbles together. So if I'm tracing what they mean by M or C, they're talking about these two all together. So let me call these regions A, B, and C, okay? So that we can see. Say this is A, this is B, and this is C, okay? If you add A, B, and C together, you will get the probability of C or M or C. So that will add up to 0.524. You know how much these two individual pieces are. So what we're going to do to figure out what's in this much, well, we're simply going to subtract 0.524 minus these two numbers. So let's do that. 0.524 minus, but hold on a second. I was going to subtract these two individually, but we do know how much the yellow piece is already. The yellow piece is 0.048. So I can just subtract this yellow from this total, and then I'll be able to get how much it is in this region C. So 0.524 minus 0.048 equals 0.476. Now, their final question was this. What is the probability of being in M? So you notice that a probability of being in M is not this region, right? Just B and C together. So how are we going to find the final answer? We'll take this number. Oh, my marker's out. We'll take this number, and then we will add this number. Okay, so if you add these two together, you will get the probability of M. Now, I'm thinking maybe there's like another way of seeing this, but that's how I saw it. 0.044 plus 0.476. If you add them together, we get 0.52. Therefore, the answer is 0.52 here. But then really the easy way to do this problem is draw a Venn diagram and try to place these numbers in each of these the regions. Okay. All right. That one was 5.2-23. But if you see another way of doing this instead of, because I think I subtracted a lot and kind of added, but that's how I saw it. If you see another cool method, just let me know, okay? I'll be back with another problem.